We'll do some example questions from 7.3 A and B. Take any homework questions. And then I have an activity for you guys to work on. You're going to be doing some mazes. It's really exciting. And while you guys are doing the activities, I'll call people up to talk about their project submissions, if you've done one, and either just like, talk a little bit about like how you might go about measuring this or whatever, and then like questionnaire construction, and have you guys, once you have an approved project, start writing your questionnaires. I've talked to some of the other senior CT teachers, and it sounds like they're willing to have to help facilitate the other CT seniors filling out surveys. So that's good for you guys, because it makes your data collection considerably easier. So we'll be doing your surveys, your questionnaires, should be constructed as like a Google form so that the data collection becomes really easy and easy to share those. So once we have project ideas settled for everybody and you can start drafting your questionnaire before we submit or send anything out to have people start filling it out, I'd like to take a read through what you've written and help just kind of tighten anything up so you get data that makes sense. But we'll talk about that a little bit later here. Everybody cool with the plan? Yay, plan. All right. So let's pick up. Hi, come on in, Mrs. McCaskey. No problem. Oh, why, thank you. That's where it came from. All right, let's see here. Picking up where we left off. So last time we were talking about dispersion. We talked about two main measurements for dispersion, those being the IQR, which you pair with medians, and then the standard deviation, which we pair with the mean as a measure of center and a measure of dispersion. So those two are frequently paired together. I think this is where we left off, right? It was on this slide. Okay. So let's talk about choosing which one to use in a given situation, because for any data set, you could do either one, right? So typically what we would say is we'd want to use the median and IQR if our data looks skewed, or if there's outliers present, or we suspect there's outliers present. That's typically the better option, as the amount of weight those outliers play into a median, or in terms of an IQR, is much less than the weight that those things have on influencing a mean or standard deviation. And then we'll use standard deviation and the mean for symmetric looking distributions that don't have outliers. And when I say symmetric, I mean like reasonably symmetric. You can be a little skew one way or the other, and that's not the end of the world. But we don't want too bad. Okay. Next we want to talk about is transforming data. So what we do is we often may want to change the unit of some of our data or all of our data to make either a calculation more convenient or the data to be uniform. So say I collected temperatures, and some people reported their temperatures in Fahrenheit, and some people reported them in Celsius. You may want to do a conversion, convert some of that data from all into the same unit, or if everybody submitted in Celsius, but you're publishing a paper in America, maybe you want to convert all the temperature measures to Fahrenheit, which is a more familiar temperature scale for your audience. So those transformations can affect the shape, center, spread of our distribution. So if I'm just adding or subtracting a constant, so say you're converting from like Celsius to kelvins, where all we do is add 273. That's an example of a unit conversion that involves just addition. So if we do that, the center, we would also shift by the same amount. So if we added 273 to each data point, the center of our data also shifts 273. And the locations of the mean, median, the quartiles, the percentiles, those all carry on the same shift, but it does not change the shape of the distribution. The IQR, the distance between the second and third quartile, will remain the same because both of them had 273 added to it. So the difference between them still remains the same. Similarly, standard deviation will remain the same. Since the mean and the data point both shift the same amount, when you take the difference, the distance between the mean and the data point still remains the same. And obviously the range is the same idea, since it's just the biggest and lowest. Okay. So let's take a look at this example. So here we have a data set, and we've transformed that data set by subtracting 13. Let's just read this. So examine the distribution of the students' guessing errors by defining a new variable as follows. Error equals guess minus 13. That is, we'll subtract 13 from each observation in the data set, try to predict what the shape, center, and spread of this new distribution will be. So this was our original data set, the guess, and then we subtracted 13 from each data point to create this new distribution. That's our error. So if we look at the original, the center of this data set appears to be, without doing the counting, probably right around here. You guys buy that? Yeah. So it looks like, what's that, between about 15 probably is what that looks like. And if we look at our shifted data set, that center looks like it's now about 2, right? How did we come up with that? 15 minus 13, so we just shifted the center, right? If we look at the spread of our data set, we went from, looks like 40 to 8. So the spread was 32, the range was 32. If I look here, I have, looks like -5, or no, let's see, that's 2, yeah, -5. And then positive maybe 28 or something, I think. That looks like it's at the 28, or no, 27 maybe, that looks in between. And if I look at the difference there, you know, we had down here, we had 32 is the difference. The difference between 27 and -5 is also 32. That range remained the same. Everybody kind of see what's going on? Okay. So if we actually ran the statistics on this, let's say we actually took the data points here and did the actual calculations. So of the 44 data points, in the original, in the guess, the mean was 16.02. In the in the new distribution, the error, after we perform the shift, the mean is now 302. What do you notice? They subtracted 13, right? The standard deviation was the same, right? Yeah, 7.14 for each. Not surprising, right? Dispersion doesn't change when we have just like a linear shift like that. The minimum, what do you notice? -13. Q1, -13. Median, minus 13. Q3, the max, minus 13. But the IQR, same, range, same. So the dispersion statistics, standard deviation, IQR, range, all remain the same. The center statistics, the mean, the quartiles, are all shifted by the same amount as the data shifted. Cool? Okay. What if we wanted to multiply or divide by a constant? So, say you're changing from, centimeters to meters, and you end up dividing by, whatever the thing is, my brain, 100. That's the factor. So, if we've multiplied or divided each observation by the same number b, the center and location, so the mean, the median, the quartiles, the percentiles, also change by a multiple of b. And the spread will change by a factor of the absolute value of b. So again, the center statistics could be negative, right? You could have a negative value for a quartile or something, like that's not impossible. But the dispersion, the spread of your data, is always going to be a positive value. So if that b always needs to make sure it's a positive value. The shape, though, of our distribution, whether it's skewed right or left or symmetric, that will remain unchanged whether we multiplied or if we added. Everybody's okay? Okay. So here, another example. Because our group of Australian students is having some difficulty with the metric system, it may not be helpful to tell them that their guesses tended to be about 2 to 3 meters too high. Let's convert the error data to feet before we report back to them. There are roughly 3.28 feet in a meter. So all of these guesses we change by multiplying by 3.28. Or actually, I guess if we took the feet and we divided by 3.28 to convert it to meters, I guess. And if we run the statistics, notice the distribution still or the shape still stays the same, right? This looks like it's skewed right with the long tail to the right. If I look at the mean here, 9.91 divided by 328 is 302. 2343 divided by 3.28 is 714. 16.4 divided by 3.28 is -5, etc., etc., etc. Is everybody okay with what we're seeing there? So on multiplication or division, depending on whether you're thinking about multiplying by 3.28 going from meters to feet, or dividing by 3.28 to go back from feet to meters, all of your statistics change by that same factor, but the shape of our distribution remained constant there. Okay. Let's look at some of these examples that we have. I want this one though. Come on there. Okay. Below is a table containing the number of calories per serving for 16 brands of frozen cheese pizzas. Find the 5-number summary for the list above. What is the 5-number summary again? Excellent. Bang. So, should we do this by hand? I wouldn't. What am I going to do? I'm going to do it on my calculator. Why don't you take out your calculator and we'll follow along and do this together, because we haven't done this on the calculator yet to see how to do this. So if you have your calculator with you, I invite you to take that out. If you are missing a calculator and you'd like to follow along, I have several backups that you're welcome to use. All right. First order of business is I have to enter this data into my calculator. The place that I go to do that is from the stat button. So see the stat button here, just to the right of the alpha key. I'm going to press the stat button. From the edit tab, I'm going to select the edit command. And that's going to open up my lists. Now, if all of your lists are blank, there's no need to do what I'm about to do. But if you have some data already entered into either L1 or L2, let's take a moment and get rid of that data before we try to enter our new data in. The easiest way to clear the entire list, which is what I'm going to want to do here because there's nothing in here I want, is I'm going to move my cursor so that it's on the title for, say, L2. Then I'm going to press the clear button. Don't press the delete button. That's going to remove the entire list, name and all, and it's kind of a hassle to get everything back. We can do it, but it's not a mistake you want to make. And then I just press the down arrow and it wipes the entire column. I'll do the same thing for L1, but before I do that, I want to point out to you that if it's just like one of these situations where it's like, oh, that 2 should have been a 21, you can just press enter and update the 2 to a 21. Or if it's like, oh, I typed in 12 here and I shouldn't have typed 12 here at all, I can delete an individual entry by pressing the delete key. But here I just want to wipe all this data. I just wanted to show you that you could also do that. So now that I have all the data wiped out of my calculator, I'm just going to enter in this data table as seen. Does it matter the order in which I type in the values? No, man. Just whatever order you want to go, whether you read left to right or up and down left to right or right to left or every other number or whatever method, crazy method you might choose to read these in. Go ahead and do that. I would say periodically take a look up at your calculator screen to make sure you didn't fat finger any of the entries because that's a tough mistake to catch unless you catch it like as you're doing it. If you type 26 instead of 260 because you kind of missed the 0 key or something, like that'll be tough to catch at the end of the day. If you're doing this like on a test or whatever, I might even recommend like as you type the number in, crossing it off your data set so you don't accidentally lose track of where you're at and forget to enter a number, type in too many numbers. So a little quick check before I move on to the next step. I notice that I have 2 rows of 8, so I have 16 total data points. If I look at my entry here, I'm on the 17th row of my list. So I know I've typed in all 16 of my data points because the 17th row is blank for me. Yes. All right, next order of business. I'm going to exit out of this menu by pressing second and the mode button. And then I'll do stat button again. This time I'm going to move to the calc menu, or I'm sorry, the calc tab. And I'm going to choose one variable stats, one variable statistic, because I have just one variable here, calories for frozen pizzas. So list 1 is going to be the list where I put my data. I don't have a frequency list here because each one of these appears just one time. So I'm going to remove L2 from my frequency list. Yours may not have had anything there. If you need to type in L1 or if you put your data, say, in L2 and you need to change this, notice above the numbers 1, 2, 3, 4, 5, 6 in blue is L1, L2, L3, L4, L5, L6. So to access those, you can press second and like the number 1, it'll type the L1 in there for you. Or if you needed L6, you press second and the number 6 or whatever. So far, so good? Okay. I'm going to now just select calculate. And so it's spitting out a bunch of information to me. It says the mean, the sum of the data points, the sum of the data points squared, the sample standard distribution, the population standard distribution, or standard deviation, standard distribution. What are you saying, Mr. Kulik? So sample standard deviation and population standard deviation, the number of data points. If I scroll down, here is the minimum, that's Q0, Q1, the median, that's Q2, Q3, and the maximum, that's the same as Q4. So that's what I'm going to be writing down as my solutions. Isn't that nice the calculator did it all for you? Because it's a hassle to like order the data from smallest to biggest. That's a pain. Like that's just time consuming. Entering it all into your calculator and just having the calculator do the sort for you and find those, those quartiles for you is super nice, right? And we talked about how to do this by hand, but in all reality on the IB exam, you'll have access to your calculator. You won't have to do it by hand. You'll be able to do exactly what we did here and enter the data and just run the statistic. Let's look at another example. You guys try this on your own right now. I'll do it along the same way. I'll scroll to my answer so you guys can check at the same time. Sound good? Okay. And again, if you have trouble seeing from where you're at, all of these are in the OneNote. So you can look at it on your tablet if you'd like, if it's hard to read from the screen because you have bad vision and still selected to sit at the back of the classroom, which is your prerogative, but maybe not a great decision. But just wanted to remind you that that is always still an option. Or if you want to go back and try these again at home because you're like itching to do more math and you're like, hey, I could do that again. That would be fun. So again, the solutions here are on my calculator on the screen. Take a moment, check to make sure they matched what you guys got. How'd you do? No problem. Pretty easy. That's good. So here it asked for, oh man, I should have done that in L2, huh? Because look at my next question. Oh, Mr. Kulik, it's using the data set that I just cleared out to put this data in. What a bummer, right? How would you do the mean for this? I mean, I would just do the one variable stat, right? Like I already potentially had this in my calculator once. Surely you could add it all up and divide by 16. That would be fine as well. Absolutely. But I'm going to just let the calculator deal with it because the longer that list is, the worse, the worse that feels. So I'm just going to do this again. And I learned my lesson this time. I'm going to save that data set that I already typed in because I don't trust myself not to do the same thing again. Right? I'd be a bummer to have to retype in that other data set now again. And again, I'm just kind of periodically checking as I type these numbers in to make sure that I didn't finger anything, that I didn't actually type 36 instead of 360.
Did you miss 340?
I think I missed 340. Well, that is excellent. Thank you. We're going to check here just in a second. I might have even done that on purpose because notice I have 15 data points entered. See how easy it is on the test. What would I like to be doing? Like crossing them off as I enter them so I make sure I don't skip one like I just did here. Diego, you said this is the one that I skipped was the 340?
Yes.
Yeah, I think you're right. Good job. Caught it before I even got to the end to do the check, but that's great. I appreciate you paying that much attention. That's fantastic. As a student, I would have been zoning out while my teacher was entering data into the calculator. I don't blame you if you were. So again, I'm just going to do stat, calc, one variable stat. This time though, I re-entered this data into L2. So I'm going to update my list to L2 and run a calculate. And my mean is X bar, so 328.75 calories per serving. Cool. Again, you could have added them all up and divide by 16 Prospectively, though, like the data was already in your calculator, it's probably faster to just do the one var stat again. What if we're given a situation like this, where we're given a frequency table, and we want to find the mean for this? If I had to do this by hand, how would I do this?
I'll do each of the books times the frequency.
Great. Yeah, so 0 times 2 plus 1 times 6 plus 2 times 5 plus 3 times 7, etc., all divided by 30, which is the total. Excellent. Or, again, I could do this with a list on my calculator. I'm going to type this stuff into L3 and L4. And we'll show you guys how to use the frequency list when we run our one variable statistic. Because remember, even though there's 2 columns here, it's just one variable, right? Oops, that's supposed to be a 6. Right? The one variable is the number of books. And again, a nice quick check is that I have the same number of data points in each of these 2 columns, so I have a frequency for each of the measurements. I have 7 total columns. I notice that I'm on L8 or L4 of 8, so I have 7 data points above it, so I know I've entered everything in. I can do a quick once over and make sure I typed all the numbers in correctly, but I'm pretty positive I did that. So I'm going to exit out to the main screen, stat, calc, one var stat. This time I'm going to do L3 was where I put the measurements, and L4 is where I put their frequencies. And now I'll hit calculate. So the mean for this is 2.8. So that's the average number of books. Everybody's okay with that? Okay. What if we're given a grouped frequency chart where we have like a range of values? What are we going to do? What do we need to use here? Yeah, the mid-interval value for the grades, right? So instead of using 65 to 69, what am I going to be using? 67, right? The mid-interval value for that. Okay, so I'm going to actually write these down. Actually, I can write them just down into my calculator. That's probably just as easy. They're going in there anyways, right? Stat cal or edit. Guess these are going to be L5 and L6. So I have 67. What's the next one? 72. And the next one? Just yell them out when you know. 77. Loud and proud. There you go. Yes. Great. And then we'll do the frequencies. 1, 1, 3, 4, 5, 6, 4. Okay. And then we'll, again, one variable stat. This time I'm in 5 and 6. So my mean there is 86.375. Cool. Again, notice the process here is like almost exactly the same, right? If I look at the next one here, What do you guys notice about the grouping for this? Thank you. That was supposed to be. What do you notice about the grouping for this one?
Boundaries.
Yup. But what is the format though?
Less than.
Mm-hmm. Yup. Does that mean anything different when we do our mid-intervals? Is that going to change anything? I'm just asking. Maybe the answer is no. Oops, that's not what I wanted to do. Well, that was what I wanted to do. What do you think?
I think it does.
Yeah.
Difference.
Yeah. So it might, right?
You know,
What do we have to be careful about here?
don't use the number on the right. Take 12. 13.
Well, right. I mean, assuming that you are rounding, right? Basically, we're going 10.5 to like 12.5, right? So 10.5 we'd round up and 12.5 we'd round down. I'm sorry, why did I write a minus between these? Goodness, great googly moogly, guys. Great googly moogly. Do you ever have one of those days?
Yeah.
Is it happening right now? It might be. So 11.5, right? Wait a minute. Is that what we expected? Yeah. So did it really matter? Okay. But it was good to talk about it, right? Talk it through, think about it for a moment, see what happened. Right? Last thing we want is something unexpected. So to find the mean, again, what do? Enter all the data, right? Before I erase this, I'm going to just go back and check to make sure I'm not going to need the other things of before. Oh, yeah, it does ask us to go back and find the modal classes. Oh, that's easy, though. Okay, I don't need you guys anymore. See you later. See you later. Again, do this with me, right? You have your calculators. Just practice typing the stuff in. It's good practice. If anything, it'll just help you identify places where you are more apt to make like a silly mistake. Like, do you have trouble keeping track of the numbers on the list so that you'll have to be careful about that on a test or a quiz? Do you have trouble like pushing the buttons consistently and you fat finger stuff all the time? Like, I'm a fat fingers person. I just get going too fast, and like, it's a good idea to practice the actual punching of buttons. Plus, nothing cements it in your memory like actually physically walking through the process of like typing stuff in. Oops. And then this is in L1 and L2 now. Yes. So our mean there is 14. Is that what you guys got?
Yeah.
You guys okay? All right. If we want the modal class for these last three with the frequency tables, how do I do that? Do I need my calculator to do this? No, man. What's the modal class for this one going to be? Which class is the most frequently occurring? 13 to 14, right? How about what's the modal class here?
90 to
Good. What's the modal class here?
3.
Okay. All right. Easy enough there, right? Ooh. Make a stem plot. What do you need for the stem plot? You need the 5-figure summary. You need that 5-figure data. So you need the min, Q1, Q2, Q3, max, right? So how are we going to get those? I would enter that data into my calculator and let the calculator handle it. I think it'll be faster than even trying to order them on the number line. I'm just going to put these into L1 on mine. What else do you notice about looking at this list? McDonald's has some fatty sandwiches, huh? Ba-da-ba-ba-ba. I'm loving it. All right, 6, 9, okay, 9. Good, I have got them all. All right, exit out of here, stat, calc, 1 var. I got to get rid of the frequency list, right? All right. When I draw my stem plot, how do I use these numbers now? Isaac, are you saying something?
The middle part.
The middle part. So here's like my number line, right? So maybe 0 and 35, 5, 10, 15, 20, 25, 30, 35. Okay, and you said, what are we doing here now?
I thought it was a step.
Yep. Yeah, but we need a scale on it, right?
Yeah.
Oh, stem plot. Oh my goodness, I'm doing a box and whisker. What in the heck is going on today, Mr. Kulik? I don't know.
It's Thursday.
It is a Thursday. Yeah, it's super Thursday.
I have to say I was really interested in your approach to why you needed the 5-number summary.
Yeah, I just,
I didn't know this. I want to see.
yeah, I because I'm doing the wrong thing is clearly what's going on. Yeah, I mean, we need it eventually for part D, but oh my god, yay. All right. The stem plot. Me. All right, so what numbers do I need as stems?
0.
0 to 5, 5 to 10.
I don't think we need past 3, do we?
No.
Okay. So what leaves do I need on 0? In the correct order. 9. Okay. How about for 1?
4, 2, 9. Twice.
2 9s. Thank you. Oops. Okay. For the 2s?
0, 2, 7.
Okay. Anything else?
33.
Okay. Am I done?
Need a key.
I need a key. Yes.
Got that off.
What should my key say?
3. Like represents a McDonald's sandwich with 33 grams of fat.
Great. Everybody feel okay? Don't forget your keys. A lot of us did on the last thingamajigger. Quiz, test. You weren't the only one. I'm not calling you out specifically. I'm calling out the students in class that forgot specifically, not necessarily you alone. All right, the mean for fish and chicken. Do I need to do the mean on the calculator for this? I would not. Because what do you notice? Oh, I guess these are all fish and chicken sandwiches. Never mind. Yeah, just regular old mean from the thing that we already did, right? I thought there's a Big Mac or something snuck in here. I guess not. Everybody's okay there? And the median, we got that also. And then the premium crispy chicken sandwich is a potential outlier with its 33 grams of fat. Is it an outlier? Let's check. How do we check? What? Well, that's the second part, right? That'll tell us how much it would have changed.
Yep.
We use 1.5 times the IQR. If the number is bigger or smaller than that, respectively, we can call it an outlier. Or I'm sorry, it's the median plus 1.5 times the IQR. So, oh man, I lost it. Give me it back. Give me it back. All right. I better write it down. So the IQR is going to be
5.5.
So it's Q3 minus Q1, right? So 9.5. So we have 19 plus 1.5 times 9.5. What did you notice here? Just squeaks under. So not an actual outlier, right? Or at least according to that criterion. Everybody's okay? How much does this removal of this sandwich change the mean and the median? Well, let's, I guess before we go, let's, oops. I gotta do it a bunch of times. Better write those down. 1989. And 19 was the median. I remember that. Okay. So what's the easiest thing to do? I'm just going to go back to this data set and, oops, scrolled right past it. Just pull out that one value by pressing delete. And then just rerun that statistic. So 1825. And my median is still 19. Whoa. Which one was more affected by that large data point? The mean. Oh! What does that tell us? More affected by an outlier than the median, yes. So the mean is much more sensitive to skewed or outliers than the median is. Absolutely the conclusion we should reach. This is running a little bit longer than I'd like, so we're going to just do parts of this. That's more than I want to do. All right. So let's just take this data set here. So this is more McDonald's data, right? This time instead of chicken and fish, it's beef sandwiches. I noticed though that it's not much different, right? That chicken option is not necessarily really much healthier than the beef option. Aside from that Big Daddy 43 fat over there. I don't know what that sandwich is. You think what, like a double quarter pounder? Who's my McDonald's aficionado who could tell me what would that be? Zach, you're the McDonald's aficionado? Wow. I'm just like a double cheeseburger person, probably.
Do you get a Coke?
Yes,
Yeah.
of course he does.
Yeah. What do you think? As I'll
He told you.
have some soda at 8:35 in the morning here.
I know. I did too, and everybody looked at me like I was crazy yesterday.
It'd be like, have you seen Mr. Kulik?
Yeah.
Not a crazy person. All right. So entered in the data to get the IQR, remember, is just Q1 or Q3 minus Q1. So in this case, that IQR is 8. 29 minus 21. Determine if there's any outliers. So I would do 26, the median, plus the IQR, which is 8. 26 plus 8 is 34. So that's the 43 is an outlier. But what other direction do we have to do? Oh, I'm sorry. I didn't do 1.5, did I? I just added the IQR. Whoa! What's 1.5 times 8? Quick in your head. 12 is right. Good job. So 26 plus 12 is 38. So yes, this guy's an outlier. But we also have to check the other direction. 26 minus 12 is 14. So these two are also outliers, right? Make sure you check both ends. It could be too small outlier also. Usually we think of always the outlier being too big, but they might be too small. Okay. The 5-number summary for this we just did. It's staring us right in the face. And then the SOX for this. What does that SOX stand for again? Do you guys remember? Shape, yes, good. Outlier, center, and spread. Very good. Okay, so what does the shape look like here to you guys? If you can't tell from looking at, what else could you do? Might just like a dot plot would probably be sufficient to get a good shape of this. Although for me looking at it, I notice like most of the stuff is just here in the middle, right? And you have a little bit of like outlier tail at either end. But that looks pretty symmetric to me. I'm suspecting that when I went and dot plotted, I would feel the same way. Outliers we just did, right? What were the outliers again? 9, 12, and 43. Gabber, you have a hand up, or are you just resting? Okay. The center. Big question, though. Should be using a median or a mean? What do we think? I think median is right. Why the median over the mean? Because you have the outliers. Yep. Now, probably in this case, it probably wouldn't make a massive amount of difference because the outliers are, you have like one at, or they're at both ends. So it probably wouldn't be that bad, but I would still do the median. And then the shape. If we're using median, spread is the last S. We already did the shape. Since we're doing median, which spread statistic should we be using? IQR, right? Is that right?
Yeah.
Yes. Yes. All right. This is the same set of questions again. So I'm going to skip this example 4 in the interest of time. So here we're asked to find the variance for this data set. How do we do that? And it says to construct a table to do so. So remember, the variance was the average distance. No. Let me say this the right way. What do you need to do? We look at it's the average of the distance squared between the data points and the mean. Right? You tell me, Mr. Kulik. That's right. So to do this, I would probably try to do it in a list here. So let's show you kind of how to do that. So I'm going to use a couple of lists, and I'm going to use those to kind of generate this. So I'm going to start just by entering this data set into L1. Okay, everybody does all right? Did I miss one again? 25, 22, 20. Ooh, I did miss 25, didn't I? Thanks, dude. See how easy it is to do this? Ay, ay, ay. All right. I'm going to start. I need the mean. So I'm going to just figure that out. Again, I'll ask the calculator to do it for me. So the mean there is 24. So what I'm going to do now is I'm going to go up to L2, the title. I'm going to press enter. And what I'm going to type in is I'm going to type in L1 minus 24 and press enter. And what the calculator has done is taken the mean and subtracted it from each of the data points, and that value is there. Everybody's okay with that? Now I want to find that so that's the distance from the mean to each data point, right? Now I want the squares of each of those. So I'm going to move to L3. I'm going to put my cursor up on the title. I'm going to press enter. Notice now my cursor's down here at the bottom. I'm going to do L2 squared and press enter. And there is the squares of each of these. And now I'm going to add up all the data points in L3. Now I could do this by hand, or I could ask the calculator to do this for me. I think I'm going to ask the calculator to do this for me. So I'm going to press stat, calc, one variable stat. I'm going to use L3 this time. And I'm going to hit calculate. And this right here is the sum of those distances squared. So sigma x is the sum of your data points. The data points in L3 were just the distances squared. And then I want the average of that, or average of those distances. So I'm going to take that and divide it by 7, but that's really the same thing as the mean here. So that's my answer for the variance, is this 5.4. And the data, or the table that I would have supplied would have been this L1, L2, L3. Is everybody okay with how I did that? Okay. What if I want the standard deviation of this? So remember, the standard deviation was the square root of the variance. So I would just be taking the square root of that x bar. I don't know, 3 decimal places. So about 233. Everybody's okay with that? Notice that I also, to get this same standard deviation, I could have, ran the one variable statistic on the original data set, L1, and pulled it from the population standard deviation listed here. Remember, in the IB SL, all the standard deviations are always population. So it's always the sigma x, not the SX. Okay, so in words, what is this standard deviation saying? So say if we randomly selected a classroom from this group of 7 classrooms, from this data set, on average, there would be, that classroom would be 2.33 students away from the mean of 24 students. So maybe 2.33 more or 2.33 less. We don't know which one, but like on average, that would be the distance of a randomly selected classroom from this data set to the mean. Okay. And let's, oh boy, I'm just blown my whole plan for today. That's okay. This is important, right? Let's do a good job. All right, let's look at this example 7. So you're given a dot plot and the summary statistic for a sample of 30 test scores where the maximum possible score was a 50. Suppose the teacher curved the test by 5 points. That is, we added 5 points to every score. How would this change affect the measures of center, spread, and location? What would happen to the shape of the distribution? So the mean would be what after the curve? $40.8. Excellent. The standard deviation would be the same. Adding doesn't change the spread. The minimum would be 17. Q1 would be 37. Median, max, 53. IQR, same. Range, same. So notice the measures of center, the mean, and then the 5 Q0 through Q4 all change by whatever the scale factor or the scaling amount is. But your measures of spread, your standard deviation, your IQR, your range, stay the same. All right, part B says, what if instead of curving the scores, the teacher took the original test scores and multiplied them by 2 to figure out percentages? Since the test was out of 50, how would that change the measures of center, spread, and location? What would happen? Oh, we didn't answer the distribution. What would change in the shape of this distribution? Nothing, right? Stayed the same. It just shifted, everything's just shifted right 5 units, but the shape is still the same. It's, what would we say the shape is here?
Skewed left.
Skewed left. Good. You see the big long tail to the left. All right. So here we're going to multiply the scores by 2 and turn them into percentages. What would the mean turn into? 71.6. Yep. And the standard deviation? 1634. Good. And what about the rest of them? All multiplied by 2, right? That's the takeaway. And the shape of the distribution? Still skewed left, right? What's it going to look? What's the dot plot going to look like? Like it's stretched out a little bit, but it's still the same shape. Okay. What do you guys think on these? Is this okay? All right. So the activity I'd like to table to next time. That's not something I'm going to be able to get to today. Where did I have that other thing? It was here. Okay. Hold on a second. Did I make a mistake back here? Hold on one second. I'm sorry. Let me go back to this real quick. Where were we doing I think I just said something completely wrong to you guys. Hold on one second. I need to fix that. Where were we doing that? This was the spot. When we were doing this outliers, did I say when we did the 1.5 times the IQR as the outliers test? What did we add or subtract that to when I did that? Yeah, that's wrong. That was wrong. I just realized that, like, what did I say back? Okay. You don't remember. Well, that was wrong. The median would be wrong. If that is indeed what I said, which I think I might have, Isaac. Yeah, so this is what you do. For the upper outlier, it's 1.5 times IQR plus Q3. And for the lower outlier, it's 1.5 IQR. I'm sorry, it's Q1 minus 1.5 times the IQR. My apologies on that. Please note that I misspoke there. So I think if we do that, I would wager 43 probably still makes it as an outlier in 9, but I bet we lose 12. We could do that again real quick, but I think I've already cleared this data, and I don't, in the interest of time, I don't necessarily think I want to type it all in again and double check. But looking at it, I bet that we lose 12 because it was pretty close before. Okay. All right. Do you guys have homework questions? We wanted to do that. We can still do that. Has anybody started the 7-3 stuff yet? That's okay.
I'm just being realistic.
No, you can.
In the math book and
You can be real. That's okay. All right, so let's talk then about the agenda for the following week, right? So we're going to do the activity, and we'll have our meetings about the project.
what is the activity?
You're going to time how long you go through some mazes. Yeah, it's going to be fun. And then we're going to do some analysis on your scores. I know. Don't practice mazes. You don't need to worry about it. It's not a big deal. You will not be graded on how fast you're able to do the maze or not do the maze.
On the internet.
Okay. So we'll do that next time.
Delicious breath of
Delicious breath of green.
Yeah.
Mr. Cool.
Which one is the like? Is that metaphor or simile?
That's simile.
That's simile.
I don't think it's comparing it.
That's what the guy is delicious for that.
It's giving, I mean, it's not personification. It's not like it's human characteristics to a
This delicious bread.
inanimate object.
It's not a metaphor. It's descriptive.
Yeah, so if you sent me stuff here in the last day or so, I am going to get back to you on those. It was supposed to be due yesterday, but it's okay. So if you haven't sent in a proposal, please do so. I'll be getting back to you guys. Hopefully today, if you sent me something and you haven't heard back from me so far. So we're going to do this activity next time. And then we'll do like a review day. And then we're probably looking at a Chapter 7 test.
Next Friday.
You got this, guys.
So again, think about what we've done in Chapter 7. Is there anything that you can't do on your calculator?
Yeah.
Not really, right? It's all calculator literacy. And then can you draw the graphs? Like, can you draw a stem and leaf? Can you draw a box plot? Can you draw dot plot? What?
How many miles?
Yeah, I'm sure they did.
They showed me homework, I was like, oh, we just did the box.
Yeah. Should we do a box and whisker?
No, I'll figure it out.
Okay. Just the box is Q1, median Q3, and then the whiskers are Q0, Q4, and any outliers are asterisks.
The line in the middle, and then the rest is 0, 4.
The box is Q1, Q2, and Q3. The whiskers are Q0 and Q4, as long as they're not outliers. Yes.
Mr.